Hi, everybody. Welcome to the Chicago Statistics lecturing series. And this is our lecture number 3. We are still working on the unit introduction of probability. So in this video, we're going to talk about kind of like applications about what we talk about the combinations, things, and how do I find the combination of index R. So we're going to introduce something we call this binomial coefficients. And also going to take a look at what is a Pascal triangle. And then the other topic we're going to talk about is multinomial coefficients here. And so for this lectures, we're going to, lecture number 3, we're going to have 2 videos. So the first video, we are going to talk about the application of these 3 things. Then the last video is we're going to discuss a few formulas associated with the combinations formula we talked about in the previous one. So this is what it's going to look like. So we're going to have some practice problems here. We're going to talk about the binomial coefficients. Then we're going to talk about what is a generalized binomial coefficient. We have a couple problems we can practice. Then after that, we're going to talk about the multinomial coefficient. Then the video number 1 will stop here. And then for the video number 2 here, we're going to specifically discuss like some of the theory related to the binomial coefficients. And so we're going to talk about the 3 very popular formulas here. So if you are in the introduction statistic class, you probably can skip the video number 2 here because most of the introduction statistics, they're not going to go this deep. If you are in the mathematical statistics class, and then you might want to review these videos here. Okay, so now let's go back, and so let's take a look at the binomial coefficients here. So let's go to the, let's go to the whiteboards here. Okay, so let's see here. Let me go back to the. Okay, so let's start to do a little bit of review, like what we did before. So like, so then you will see where we're going from here, right? Okay, so like we did in the video number 2, we talk about the combinations, right? The combinations, like we said, the notation you can use is CNR, or some people, they use like this is CNR, like this, or some people, they use like this notations, NRs, right? But the formula for here will be like the n factorial, then you take the r factorial, then this is n minus r factorial here, right? So this is what is we call this the combinations and how to find how many total ways for the combination. One of the, one of the application for here we can use is we call this the binomial coefficients. So what is the binomial coefficients here? Let's take a look at some example. We know since we were young, right? So like if you have x plus y to the square, right? So from the, from the algebra class from your high school, this will be what? This is x plus y times x plus y, right? So if you FOIL it, you will give the x squared plus 2xy plus y squared, right? So now the same way, if you remember here, so if I say x plus y to the cubes here, so if the, if you say the xy plus the cubes here, so what is that? So if you use your algebra, you expand it, you FOIL it, it will be x cubed plus 3x squared y plus 3x y squared plus y cubed here. So for here, like an x squared, let me put a coefficient here. Let's say this is 1, right? So it's 1 times, right? So let's put a coefficient here. So it's 1 time. So this is 1 times and this is 1 times here. So that means I know if I want to expand the x plus 3, x plus y to the cube, this is what my expansion is here. So the same way is here, right? So as you know, if you learned in the algebra, if I want to expand to the x plus y to the 4th, then it might take you 5 minutes to FOIL all the term. So after you FOIL it, this is going to become x to the 4th plus 4x to the cube and the y, then plus 6x to the square, y square, then plus like 4 to the x and the y cube, and plus 1/4. Then you will say, oh boy, how can you remember all those formulas here? Well, in fact, I cannot remember those formulas. But I do have a quick way I can find it, right? So like one of this the binomial coefficient is, so for example, like x plus y to the 4th here. Then they say, hey, what is the coefficient? Okay, so what is the coefficient of, let's say, the x to the y cube here, right? So without expanding that, you know, without like carry out all the calculations, right? So without like doing all the multiplication. So how do I find what is the, what is the coefficients? So if you carry out, then I know it's 4. But like if I say x plus y to the 10th power, it would be very difficult to carry out. So we know the xy to the cube is here. That means, for all these terms here, right? So that's what is this formula tell you. They say, hey, for all these terms here, n the what? N to the r's, right? So like y is the cubes, right? So that means n to the r, or, in these examples here, you will say it's 4. I take 3, right, to be y, and the 1 to be x here. Then let's see what is the coefficients, right? So if you put this one into your calculator, you get this is a 4 here. Okay, so that's why we said for any, okay, so that's why the first formulas, right? So we talk about there is for any x plus y to the nth powers, right? So what is the coefficients? Like if you have x to the n minus r plus n minus r and the y to the r's power. So what is the coefficient? So the coefficients here will just be what is n to the what? N to the r's here, right? So like for here, the x to the y cube. So r is 3 and x equal to 1, right? So n equal to 4. That's how do we figure, that's what we call this is the coefficients of the binomial expansions here. And we also can use another easy way, so we call this a Pascal. If you look, the Pascal triangles here, right? So if you look here, this is 1. So with the first degrees here, right? So we talk about x plus y to the nth power, right? So talk about to the nth power. So when n is equal to 0, this will just be equal to 1, right? Because x plus y to the 0. Then also if you say here, maybe I put a Pascal over here a little bit to get more space. Okay, so if n is equal to 1, right? So you will just be the x plus y. Then like n is equal to 2, it will be x plus y to the square, just like we did here. Then the n equal to 3 will be x plus y to the cube, right? So for the Pascal triangle, so like the first things here, you can put like this is 1, right? So this is 1, 1. You put the coefficients, right? So this is the what? This is when n equal to 0, right? So this is when n equal to what? when n equal to 1, right? Okay, so now when n equal to 2, right? So see here, if you take a look here, what is the coefficient here? Is the 1, 2, 1, right? So the way you can say here, this is 1. So how do I get a 2? You add this 2. So this is 1, 2, 1, right? So this is when the n is equal to what? Equal to 2. So when n equal to 3, take a look, the coefficients here. This is 1, 3, 3, 1. So what is the 1, 3, 3, 1? So you start with 1. Then this 2, you add it. Maybe you want to use a different color. So okay, so you add this 2, you add this 2, just like in here, you add this 2, give you 2s, right? So you add this 2, 1 plus 2, this is 3, this is 3, this is 1, right? So this is how do you expand n is equal to 3 here, right? Okay, so now when n equal to 4, just like in here, we have 1, 4, 6, 4, 1. So you have here is 1. Okay, so now you add this 2, this 2, this 2s, right? Okay, so you have 4, 6, 4, 1, right? So this is n equal to what? This is n equal to 4. And so if n equal to 5, you can do the same thing. This is you add this, add this, add this, right? So what do you have? You have 1, 5, 10, 10, 5, 1, right? So this is n equal to what? N equal to 5 here, right? Okay, so also if you take a look at how the power decreases here, right? So take a look here. Let's take a look at these numbers here. So like x the cube, right? So you start with x equal to the cube. So x started decreasing the 3, 2, like this is 1s, right? So this is 3, 2, 1, 0. So the same way, then the y is start to increase from the 0, 1, 2, 3. Did you see that? All right. So that's what happens here. So this is 1, right? This is 2. This is 3, right? So that's why x decreasing, y increasing the power. So you can use the Pascal triangles to do that. So for examples here, like if I said, okay, I want to do x, let's try to do here, like if I want to do x plus y to the 5th powers, right? So if I want to do x plus y to the 5th power, so then I say here, I start with the, here, okay, so it's the 1, so I start with what? I said x start with the 5th power, right? Now I go down to the next coefficient, so this will be 5. Then x decrease 1, so it's 4. Then y become 1. So 1 and 4, they always have to add up to the 5s, right? Then the next ones here is 10. So the x just continue to drop, x cubed. And then at the same time, the y going to increase. So it's 2, 5. See here, right? Because when this one and this one, it always has to be equal to 5s, right? Okay, so now you continue. So it's 10 tenths, right? So this is 10 x to the square, y to the cube, and then 5 x to the 1s, and the y to the 4th, then finally x to the 0 and the y to the 4th, right? So that's how do we do the expansion. So with the help with Pascal or with the help with the combination notations here, we'll be able to find the coefficient. We'll be able to expand it a lot easier than use the algebra just to multiply all the terms out. It might take a while. So for example, x plus y to the 4th might take you 5 to 10 minutes and try to multiply that out here, right? So that's what we talk about the binomial coefficients here. And we're going to use this in the later lectures when we talk about the probability distributions. And we will use this binomial expansions again here. Okay, so that's what is the first things we call is the binomial expansion, binomial coefficient. And then here, in order to match the, in order to here to the NR is the same way as the Pascal triangles here. So both the N and the R, they has to be what? They has to be whole numbers here, right? So the both N and the R has to be whole numbers. And but we do can have the, if it's not a whole number, so what can we do? That's why the next ones we call it is like we generalize. Okay, so we have a generalized binomial coefficients. Okay, so the generalized binomial coefficient, we still use the notation n to the r's here, but the n's here, right? But the n's here is not necessary to be integers anymore. Okay, so that means you don't have to be the whole number. So what's that mean? That means that I can say what is the 1/4 to the 3. Okay, so what is the, so the 1/4 take 3. So what's that means here, right? So in the generalized, the binomial coefficient, the formula is very similar here. So it's n to the r's here. This will just be the same thing. The bottoms here, this is r factorials, right? So the top here, right? So it's not n factorials anymore because we cannot, find the factorial on the not whole number. So the top here will just be n minus 1 is very similar. Then the n minus 2, your times is to n minus r plus 1 here. So basically, if your r is 3, you times the 3 terms. R is 4 here, you times the 4 terms here. Then you will wonder where we use it. The generalized binomial coefficient, we use it, mostly in the calculus 3 when we talk about the Taylor series, so talk about the series expansions. So we do talk, we do use the binomial coefficient when the generalized binomial coefficient when the n is not necessary to be a whole numbers anymore. Okay, so you remember here, right? So in here, the r's here has to start with 1, 2, and here, whatever the numbers you have here, right? Okay, now in here, let's take a look. Okay, so let's go back here. Okay, let me see here. Okay, let's go back here. Okay, so that's what is the formula we just did here. So we call this a binomial coefficients, and how do you do that? And the Pascal. And then here, this is the generalized binomial coefficient. Notice the differences here, right? So n doesn't have to be whole number, and r can be 1, 2, 3, 4, 5, here to whatever the number. But in here, right? So the r here for the, for these numbers here, the r's here has to be from 0 to n here. Okay, so that's the differences here. Okay, so now let's take a look at our problems here. Let me go back to the whiteboard and let's take a look at our problems. Okay, so now the first one's here. Okay, so let's take a look here. The first one's here, it said, find the coefficient x squared y cubed in the expansion x plus y to the 5th power. So we know the coefficients here is n to the r's, right? So the n to the r, so total, the n is what? Is 5, right? So that's why we said this is a 5. And the r is the what? R is the, in fact, it doesn't really matter. R is the coefficients here, right? So this will be 5 to the 3 So what is the 5 to the 3 here? If you put it into your calculator or you put a definition, so will be the tenths here, right? So that will be the x squared y cubed term. So if you go back to here, x squared y cubed, x squared y cubed, right? We just did these examples here, x squared y cubed. Hey, what I have here, my coefficient is 10, right? That's just what we did. Okay, so let's see here. Let's take a look at next problems here. So I'm same thing, I'm going to find the coefficient of x squared y cubed. But now I am in the x minus y to the 5th power. Okay, so I know the coefficients here, right? So coefficients here is 5 to the 3. So this is 10, right? We know that is because this is the 5 and this is what? This is 3, right? But, you know, in here, take a look here. Okay. So this one's here, the x minus 5, x minus y to the 5th. You can rewrite this is x plus what? Negative y to the 5th, right? So these coefficients here, this coefficients really is in front of 10, right? So the x is here, the x to the square. Then the y, but the y here is negative y to the how many power? 3rd powers, right? So I know the 3rd power to the negative still is negative. So it's negative 10 x squared y cubes here. Do you get that? Okay, so now I know what? I know my coefficients for this ones here is negative 10, right? Because here, right? Because the x minus y is equal to x plus minus y. So the y cube really is negative y to the cube. Okay, so let's take a look at this ones here, right? So this one is 2x minus 3y to the 5th power. Okay, so the same way, I know my coefficients here, right? So the coefficient has to be 5 to the 3, like we did, so it's a 10. Okay, but now this one's here, right? So you can rewrite this one. This is 2x plus negative 3y to the 5th, right? So if you rewrite it, this is really is your x, this is your y's, right? So the x squared, so x squared y cubed will be 2x to the square, and then negative 3y to the what? To the cube, correct? Okay, so now you take this one out, 2, so this is 4x squared. So 3 to the negative 3, what do we have here is negative what? 27y cubed. And I'm only looking for the y cubed. So 4 times negative 27, so this is negative 108 x squared y cubed, right? And don't forget, you still have here. So what is the coefficient in front? So what is the coefficient for the x squared y cubed? What it will be? So it will be negative 1080. Correct? Okay, so that's it. So be very careful, right? So you know that we have the binomial expansion NR, it's just x plus y. And now you here, we can make some changes here, and then your coefficient going to change here, right? Okay, now let's take a look. Okay, so number 4 is here. They say use the generalized definitions to find the binomial coefficient. The first one is 1/2 to the 4th, right? So for 1/2 to the 4th, this is my n, this is my r, right? Okay, so let's see how do we do that. So the 1/2 to the 4th. Okay, so this will be, the bottom is 4 factorial. Correct? Okay, the bottom will be 4 factorial. Then the top start with n, so it's 1/2 times 1/2 minus 1, right? Then times 1/2 minus what? Minus 2. Then times 1/2 minus 3. See here, because the bottom is 4, so you multiply 4 terms on the top, right? Okay, so now let's take a look. 4 factorial is 24, right? So we know the 4 factorial is 24. So this is 1/2 times negative 1/2 times negative 3/2 times negative what? 5/2, right? Okay, so like so 2, 2, 2, 2, so this will be 24 times 16 and the negative 15, right? So if you simplify a little bit, this will be negative 5, 128, all right? So that's how do we use generalized binomial coefficients here. Okay, so let's take a look one more. So for this one, the n is negative 3 to the 3, right? Okay, so it's negative 3 to the 3. So just like we did before, the bottom is 3 factorial, right? So the top start with negative 3, then times negative 3 minus 1, negative 3 minus 2, and because here is 3, so you times 3 terms here. All right. So now let's see here. 3 factorial is 6, right? So this is negative 3 times negative 4 times negative 5. So it will be negative what? 60 over 6 here. So it will be negative 10. You get that? Okay. So that's how do we use the generalized coefficient. So the problem number 5 is kind of like, so why we need this, right? So this is how do we be able to approximate here, okay? So think about it here. I want to find the square roots of the 5, right? So how do I find the square roots of the 5? So first thing we say, hey, I can rewrite the square roots of the 5 is equal to 1 plus 1/4 to the half. So let's see if this is true or not. Okay, so 2 times 1 plus 1/4 the half, right? So this will be 2 times, so this is 4, common denominator is a fifth, 1/2, right? So the 1/2 is the square roots. So this is 2. So what is 4 square roots? Is 2, right? So this is square roots of 5. So that's why we said the square roots of 5, I can write it 2 plus 1 plus 1/4 to the square roots. So then we said, okay, now I can use the, the binomial expansion to estimate. So let's say use the first 4 terms of the binomial expansions to forecast the square roots of the 2 to estimate. So you will see how close we get it. Okay? Okay, so let's take a look here. Okay, so 1 plus 4, right? So this is 1 plus 1/4 to the half, right? Okay, so the first one's here, right? Remember the binomial expansion. So think about this is x, this is y, right? So first is the, so I can start here. So this will be, so what here? So it's 1/2. You take the 0 powers, right? 1/2, you take the 0 power. So r equal to 0. So this is 1 to the what? 1 to the 1/2. Using the binomial expansion formula we talk about, right? So this is 1/2. This is 1 to the 1/2. Then this is 1/4. R equal to 0, right? So 1/4 equal to 0. Then plus this is 1/2 to the 1. All right, so this is 1. This is 1/2 minus 1. So it's negative 1/2. Then here, this will be 1/4 to the 1/2. Oh, I'm sorry, 1/4 to the 1s, right? R equal to 1s here. Okay, R equal to 1s here. And then we have 1/2. You take a 2 right now, right? You take a 2. Now here, the x here will be n minus r, right? So it's 1/2 minus what? Minus 2, right? Then is y is 1/4 to the second, then plus 1/2 to the 3. Then here this is 1, this is 1/2 minus 3, then this is 1/4 to the third power, right? So what I did here, if you know, we just did this, so I'm just using the x plus y to the nth power. So how do you expand that, right? So that's how do you expand that. We did, so like this one's here will be like n to the r, you know, summation n to the r, x to the n minus r, and the y to the r's, right? That's why I'm just using it. And then now I can find it. Okay, so I can simplify this one. So 1/2 to the 0 is 1, right? So this is 1, then plus 1/2 to the 1. So this is 1 factorial, you times 1, so it's 1/2. Then this is 1/2, because 1 to the any power still is 1, right? Then the second one's here, this is plus the 2 factorial, then this is 1/2, then this is 1/2 minus 1. Then all these terms here, right? This is 1's terms, right? So all these terms become what? Become 1's, right? So I don't need to worry about that because it's the 1's to certain power, right? So this is 1. Okay, so now this is a plus. Okay, so I'm sorry, I did not finish this one yet. Okay, so this is 1, and then times 1/4 to the second, then plus, this is 3 factorials, right? So 3 factorial, so this is 1/2, then this is 1/2 minus 1, 1/2 minus 2, then this is 1/4 to the third, right? Okay, so now you plug these ones here into the calculator. You got this is 1 plus 1 over 8 and minus 1 over 128 plus 1 over 1024, and I'm getting is 1145 over 1024. Okay, so now I know the square roots of the phi can be estimated by the 2 times the 1145 1024 here. So I will get the number is 2.23632. All right. So if you put the square roots of the phi into a calculator, so here this is the calculator numbers here, right? So like if you put it into the calculator, so I know the square roots of the phi is equal to the 2.2360679. As you can see, it approximates quite well, right? So this is 2.236 and 2.236. So it approximates very well. So, but why you ask why this is approximation? Because for this generalized binomial expansion, if I want, I can add to the infinity terms, right? And then here we say I only want to use the first 4 terms. That's why its approximation is not going to equal to exactly what is the square root of the phi here. So that's what you see here. You know, the generalized binomial coefficients, we can use it, and you know, that's why we can use it to expand a series, right? So that's what we learned in the calculus. You know, we talk about the binomial expansions also. Okay, so that's it. So that is the what is this video? We just kind of an application of the, you know, the way we talk about the combinations, the CNR. And unfortunately, for the TI-84, if you have a generalized binomial coefficient like a -3 to 3, or, you know, like if you have like a 1/2 to the 4, so negative 3 to 3. If you put it into the TI-84 calculator, the CNR function, it will not work, right? So because the CNR function will assume both N and R are the whole numbers here. So the generalized ones here, that means that when the N is not the whole number, then how do you do that? All right, so that's very interesting, right? Okay, so it's nice to talk to you on these videos, and so I hope you get a better understanding about the combination and the permutation and what type of this video give you a very interested applications about the binomial coefficient to make your expansion of some algebra terms a lot easier. And also then the next things here we want to talk about is, so we, this ones here is the binomials, right? So this is the binomial. It's a binomial coefficient. How about if I have, the multinomials here? Let me see if I have, so like for example, if I have like x plus y plus z plus w to the fourth power, then I want to expand it. What is the coefficient in front of each one? So how do I do that? All right, so that's why the coefficient in front of the binomials, multinomials here, let me go back to our PowerPointer here. Okay, so if you take a look here, this is the last set of the formula we're going to work about. So it's the multinomial coefficient. So that means if you try to expand it, so this formula looks quite familiar again, right? Like we did for the permutations and the combination partitions things. So will be the n factorial, R1 factorial, R2 factorial, and RK factorials here, okay? So let's take a look at our last examples here. All right, so the last example, this one's here is, I want to find the coefficients, right, of this expansions here. So this one's here will be x plus y plus z equal to 8. So I know my n's here, this is my n. So this is the total, how many times the exponents. Then in here, I will see here, the x I want to have 2, y have 3, z have 3. So I know the coefficient in front of x squared, y cubed, z cubed will just be equal to what? Will be the n factorial, right? Just like the partitions, right? 2 of the position I want to give to x, right? So this is 2 factorial. And then 3 of the position I want to give to y, so this is 3 factorial, and this is 3 factorials. You get that? Okay, so now in here, so I know the coefficient in front of this one is 5/60. All right, so that's it for this videos here. And it's very interesting applications, and I hope you got a good understanding about what is the binomial expansion and how easy to simplify, when we did what we did in the algebra, right? Okay, so it's nice to talk to you, and I will talk to you in our next videos here. Okay, if you like the video, feel free to subscribe it, and if you still get confused or have a question, leave me a comment, all right? And I will try to answer your questions. Okay, bye.